So now we will see few problems based on force and electric field intensity. The first problem is calculate the force experienced by a point charge 2 microcoulomb due to a point charge minus 4 microcoulomb in free space. The separation between the two charges 20 centimeter. So we will be using Coulomb's law for calculating the force, and this is a general expression. F is equal to Q by 4 pi epsilon 0 sigma k equal to 1 to n Qk into R minus Rk by modulus of R minus Rk the whole cube, where R and Rk are the position vectors. Now here you are asked to find out the force experienced by 2 microcoulomb due to minus 4 microcoulomb. So in this expression, this Q will be taken as 2 microcoulomb. Okay, Q will be taken as 2 microcoulomb and Qk will be taken as minus 4 microcoulomb. Point to be noted. The question, it is said that you have to find out the force on 2 microcoulomb due to the point charge. So Q will be your 2 microcoulomb. Now next what you have to do is you have to find the position vector. Now here I have drawn the diagram Q1 and Q. The separation between them is 20 centimeter. I have to convert it into SI unit, so 0.2 meter. Now in order to find the position vector, I have to find the coordinates. Here the coordinates of Q1 is 0 0 and here it is 0.20 because there is no y-axis for this Q1 and Q. Okay, so we have find out the coordinates of Q1 and Q. Now you can write the position vector. For Q1 it is 0 into small ax plus 0 into small ay, and the position vector for Q is 0.2 into small ax plus 0 into small ay. Okay, so here it is written Q is equal to 2 microcoulomb, Q1 is equal to minus 4 microcoulomb, R is equal to 0.2 AX and R1 is equal to 0 AX. R1 is a position vector of this Q1. Now I am rewriting this expression as F is equal to Q into Q1 into R minus R1 by 4 pi epsilon 0 magnitude of R minus R1 the whole cube. Okay, here the value of k is just 1 because you are having only a single charge, because in your question you are asked to find out the force on 2 microcoulomb just due to this single charge minus 4 microcoulomb. So the value of k is 1. Now you can find out what is R minus R1. R minus R1 is equal to 0.2 AX. Similarly, you can find out the magnitude of R minus R1, that is here square root of 0.2 the whole square plus 0 square will give you 0.2. Now you can substitute all these data onto this equation. So your Q is 2 into 10 raised to minus 6. You have to convert it into SI unit. Micro is 10 raised to minus 6. Q1 is equal to minus 4 into 10 raised to minus 6. Then R minus R1 is 0.2 AX by 4 pi epsilon 0 and modulus of R minus R1 you will get it as 0.2. That's the whole cube. Then you can 1 by 4 pi epsilon 0 is equal to 9 into 10 raised to minus 9, that you have to by heart. And finally you substitute the value and get you will get F is equal to minus 1.8 AX, and if you take the modulus it's enough to write 1.8, that much of Newton, that is a unit of force. So that's all. Now in the next question, what you are supposed to calculate is 3 identical charges Q each placed on the corners of an equilateral triangle of side A. Calculate the force on a charge. That means these are the 3 corners of an equilateral triangle marked as A, B, C, and 3 sides are equal distance, equal side of length A, and identical charges are placed at these corners Q, Q, Q. Now you are supposed to find out the force on a charge. They haven't specified any particular charge, so you can either find the force of the charge placed on A due to B and C, or you can find the force placed on the force on the charge placed at B due to A and C, or force on the charge due to A and B. It's not specified. So here in this question I am trying to find out the force acting on the charge placed on this corner due to the charges placed on B and C. Okay, here the whatever corner we choose as a reference, it doesn't matter because all the charges are having same magnitude, q q q. Okay, so we will be using the Coulomb's law, so we know what is the magnitude of our charge. Next, what you have to find out is the position vector. So to find out the position vector, first you have to identify the coordinates. So now listen, I have redrawn the figure like this: A, B, C, Q here, Q here, Q here. Now can see the coordinates of B is 0, 0, right? And what is C? C is A, comma 0. The x coordinate of BC is A. It is given. The side is A. And y is 0. Now you have to find out the coordinates of A. For that, what I am going to do is I am going to draw a dotted line straight down to my BC. And it will exactly cut at the mid of my BC because it's an equilateral triangle and it's symmetric also. So this much of distance BO is A by 2, right? And AB, we know it is A, is already given in the question. So using Pythagoras theorem, you can find out what is AO, that is root 3 by 2A. Now you can find out the coordinates of A. This root 3 by 2A is your y coordinate, and our A coordinate will be A by 2. Sorry, x coordinate will be A by 2. Okay, x coordinate is A by 2 and y coordinate is root 3 by 2A. That is written here. Now you can write the position vectors. Here A by 2 into small ax. Here root 3 by 2A into small ay. Here 0ax, 0ay. Here A into small ax plus 0 into small ay. Now you can find out using the Coulomb's equation. F is equal to Q by 4 pi epsilon 0 sigma K equal to 1 to 2. Here K value varies from 1 to 2 because I am going to find out the force acting at this corner due to the charges at these two corners. So you have two additional charges. So my K value is 1 to 2 and this Q will be the charge placed at corner A. Okay. So I am writing the expression. Q by 4 pi epsilon 0 sigma K equal to 1 to 2 QK R minus RK by R minus RK the whole cube. Now I am going to find out the force at A due to Q at C. Okay, I am going to find out what is the force acting on A due to the charge placed at C. So here we have to find the position vector R minus R1. That is, R will be the position vector of my A and R1 will be the position vector of my B. Listen, here I have written it as a vector of point B. It's wrong. It's the vector of point C. It was done by a mistake. So please correct it. This is a position vector of point C. Okay. So here, because here we are trying to calculate the force at A due to C. Okay. So now R minus R1, the position vector of my A is A by 2 AX cap. You can use AX cap. Cap can be used for representing unit vector. Okay, plus root 3 by 2 A AY minus the position vector of A. Position vector of C, that is A into AX plus 0 into AY. Please make the correction here. It's vector of point C. Okay. Now that is equal to minus A by 2 AX plus root 3 by 2 AY. Then you can find the modulus, that is minus A by 2 the whole square plus root 3 by 2 into A the whole square. Finally you will get A. Then we know what is the next, what we want to know is the magnitude of charge at A and C. That is easy because in the question it is said that all the charges are identical. So the value of Q at both A and C is Q itself. Okay. So I am going to substitute the I'm writing now. I'm slightly rearranging the main equation like this. F is equal to Q by 4 pi epsilon 0 into Q1 into R minus R1 by R minus R1 the whole cube. That is written here. 9 into 10 raised to 9 Q into Q1 into R minus R1 by the modulus of R minus R1 the whole cube. Now this Q will be the Q at corner A, and this Q1 will be the Q at corner C, and that is also Q, that is written here. So 9 into 10 raised to 9 Q into Q, this much. Okay, then you will get an answer. I haven't simplified it, please simplify it. Okay, now in the second case what you have to do is you have to find the force at A due to B. Okay, so you have to find the position vector difference R minus R2, where R is a position vector of my A and R2 is a position vector of my B. A, you know, A by 2ax plus root 3 by 2ay, and B is 0, 0. You can find the difference, you will get this one, and then you can find the modulus, that is R minus R2, A by 2 the whole square plus root 3 by 2a the whole square, the whole root. Finally you will get A. And now I am writing the main equation as F is equal to 9 into 10 raised to 9. That is 1 by 4 pi epsilon 0 is directly written as 9 into 10 raised to 9. Q into Q2 into R minus R2 by R minus R2 the whole cube. Here Q2, the value of Q2 is also Q. Then you can substitute it and you will get this expression. Finally, to find the total force, you have to sum A plus B. And you will get this value, 9 into 10 raised to 9 root 3 Q square by A square AY. And while you are taking the magnitude, you can remove AY. So 9 into 10 raised to 9 root 3 by A square Q square, that much Newton is your answer. Hope these two problems are clear for you.